Literature is man's exploration of man by artificial light, which is better than natural light because we can direct it where we want. This is what David Dacius said once, regarding artificial lightning. Can this be the actual truth? And how would we be able to do this without altering our world's cycle? Bioluminescence could provide an answer to these questions, and also in a natural way. What is even it? Bioluminescence is the production of light that certain living organisms are able to produce, through chemical reactions inside their bodies. The reason this is even possible, is that a molecule called luciferin is able to react with oxygen. When an enzyme luciferase is present, this reaction magically produces energy, visible in a form of light, typically blue or blue and green. This process is also really common in natural habitats. Both in marine and ground habitats, over 700 animal species and organisms have been found to be able to produce this type of light, although it's quite rare on land and much more common in marine conditions. In fact, about 80% of species between 200 and 1000 meters are bioluminescent. That brings us to our original questions: how would we be able to source this energy and reuse it? And how would we do so in an ethical way? This is where history has played a huge role. See, this would not be the first time bioluminescence has been used in an artificial way. For the first time it has actually been used as a safety lamp in coal mines. Miners used to use dried fish skins, both in Europe and Britain, as a scarce source of light. This weak natural lamp helped to reduce explosions previously caused by igniting candles in caves containing firedamp, a particular flammable gas found in coal mines. The first artificial use was in the 20th century, but it is very important to define that bioluminescence wasn't discovered then. The Greeks had their first reference to this marine lantern in 500 BC, but it will only be a decade later that the first author specifically described this phenomenon. Aristotle was observing, and he understood that some dead animals produced a type of light. Around 350 BC he discovered bioluminescence. In a time where philosophy was the only answer for everything, he found out that this light had no thermal power. So he was the first to discover that light, at least in this case, had no association with heat whatsoever, and it was a different entity. So using this type of light is indeed possible, but how efficient can it actually be, and where would it even be used? Yet again, for this question, humanity has been inspired by animals, mostly marine organisms. What's really cool about bioluminescence is that it has a bluish color, so what more could the organisms able to produce this light ask for? The answer is simple: nothing. These living creatures are able to blend in with the color of the water, giving them a very powerful weapon: partial invisibility. They can see, the prey cannot. A few of these creatures, like the genera of Aristostomias, emit red lights. These creatures live in very deep places, where because of the depth, red spectrum of light disappears, and they cannot be seen. One of them is the Malacosteus niger. Humans have found inspiration from this, in various subjects, in light production itself, in medicine, and in military. The army especially was attracted by this, during the Cold War. Submarines at the time weren't exactly advanced, and so wasn't the tech, and they paid dearly for this. One submarine was sunk, because it had been sighted. But not all of its uses are for wars. We did talk about medicine and innovation. Well, for medicine, since the 20th century, scientists have found ways to integrate bioluminescence into cures. The most relevant one is research for cancer. Bioluminescence imaging allows for advanced research of cells, by making them glow under certain conditions. Or again, this light is used for real-time monitoring of biological processes, without harming the subject tested. And again, it can detect infections or diseases before they spread, or see how they interact to cure them. As for the actual innovation itself, creativity can play a huge role into this key point. We could use bioluminescence to illuminate the cities at night, or the homes. They could be source of recycling, if we manage to make them last very long, and degrade very little. Or even make sure that every single area is lit, and everyone has access to light. There's countless ideas really, but where would you like to see it being used? Make sure to comment that. This said, we're now at our final question: what is stopping it from happening? We mentioned earlier that miners used this scarce light in mines, and even though it wasn't very powerful, it worked. The main issue that we have today is that bioluminescence is very unstable, and it requires very specific conditions, making it very sensitive. And as many things where unstable things are being treated, the cost to produce everything is very high, and the quantity of light available now very low. This is it. Thank you for having followed so far. Make sure to tap that like button to have more of these videos. And watch it produce some light too.